If we want to deal with energy, right, we just have to figure out potential energies. Now, one thing to remember is the frequency only depends on your K and your M. So period and frequency do not depend on amplitude, all right? So are measured to have a period of 0.8 seconds. That's how we're going to figure out what our omega is. We want to know what position or positions is the block speed 1 meter per second, okay? So we're just using energy the way we always have, but first we're going to figure out the period of 8 seconds, or 0.8 seconds, that's going to be equal to 2 pi square root of m over k, all right? Once you do the algebra on that, that means k is going to be equal to 30.8 newtons per meter, and this is all you're going to need to figure out what your energy is. So remember, potential energy of a spring, that's 1/2 kx squared. All right, so it's when you start out, our initial energy is going to be 1/2 kx squared. So look, we have a block on a spring. It starts out here. We pull it a distance of 20 centimeters and release it. So its initial energy is 1/2 kx squared, right? Plus 0 because it's not moving. When we want to know in the final what it's doing, so that's going to be 1/2 kx squared, and in this case k is going to be your maximum amplitude to start out with, plus 1/2 mv squared, because at some later time it's going to be either here or here, away from equilibrium, right? Because we know we want it to be going 1 meter per second. So it's either gone past or it's gone back, all right? So we just want to figure out the positions, and we know there should be 2 positions where it has the same speed because we don't care about the direction of the velocity. So we set this up. It turns out we can get rid of all the 1/2s, and we're solving for x. So x squared is going to be equal to ka squared minus mv squared divided by k, and we can say x is equal to the square root of a squared minus m over k v squared. We plug in our numbers, and this is why we needed k. Well, we lost it, but our amplitude, once we plug in our numbers, our amplitude was, let's see, the amplitude was 20 centimeters. We know it's going to be less than that because that's our maximum, so we end up with something that's 15.4 centimeters. And it's plus or minus because it can be on either the stretched or compressed side. Okay, so let's try this out. Pause and think about this one. Okay, and it turns out this is not going to change. Now, why doesn't this change? Well, does the amplitude affect the frequency or period? No. Okay, what affects the frequency or period? Well, the only things that affect the frequency or period, oh my gosh, why does it keep doing this? The only things that affect the frequency or period, right, omega is equal to k over m. So the only things that can affect your frequency and therefore your period or your other frequency are the spring constant and the mass. So period and frequency do not depend on amplitude, and you can see there's no A's anywhere in here.